Okay, so this time we're solving logarithmic equations, not exponential equations. Okay, let's have a look. Now think about all the rules you've kind of been learning about log properties. Okay, log to the base 3 of x equals -2. Well, if I change that to an exponential form, I'll have 3 to the -2 equals x. So that's one way of doing this. I can see, okay, if I change that to exponential, I've got the answer because 3 to the -2 is 1/9, and that's it. Okay, so remember, 3 to the -2 equals x, so x equals 3 to the -2, which is 1 over 3 to the +2, which is 1/9. Okay, not too bad. Right, how about this one? Now then, remember this. Two separate logs added is the same as a single log with those two things multiplied. In other words, x times x plus 3. Okay, so I've used that product rule for logs, and that equals 1. Okay, so there we go. I've just changed from two separate to a single log. Okay, but now it's a product. Okay, so if I do actually do the distributive law on that, that's log. Now remember what log is. I'm going to write it in. Log is log to the base 10. So put it if you want to. X squared plus 3x, and that equals 1. All I've done is the distributive law, okay, and written 10 in. Because, watch this, change from log form to exponential, 10 to the power 1 will equal x squared plus 3x. So again, 10 to the power 1 equals x squared plus 3x. Now I'm going to jump over to the left now, okay? Because if I take away 10 from both sides and put it equal to 0, this is what I have. Look at that. There you go, right there. Okay? Now, that will factor into x minus 2, x plus 5, so x equals 2, or x equals -5. Now, remember, these are logs. Be careful. If I put 2 back into here, it will work, okay? Log 2 plus 3, log of 2. But look, if I put -5 back here, remember, we can't log negatives. Remember that. That will not work, okay? Here we go, another one. Right, it's a subtraction. The quotient rule as a single log to base 3, which is what this is. I'm going to write this as 2x minus 1 over x minus 4. Okay, remember that? That's the quotient rule. And that equals 2. Where's it over here? There it is. Okay, right there. Again, if I do the change to exponential form, 3 to the power 2 will equal all this parenthesis. And there it is. Right there. Of course, 3 is squared. So 3 to the power 2 is 9, 3 squared. So I have that. Now that has now nothing to do with log or exponentials, it's just basic algebra. You can multiply both sides by x minus 4. You think of 9 as 9 over 1 and cross multiply. Okay? But look, I end up with this. So again, think about it. Either multiply both sides by x minus 4, think of it as cross multiplication. If you think of 9 as 9 over 1, we end up with x equals 5. Alright, and there doesn't seem to be a problem with that one. So x equals 5 is the solution. Okay? Right, one more. Okay, so again, look at this one. Log of something minus log of something equals a number. Log of something minus log of something equals another log. So all these are logs, but let's still do the same thing. So again, as a natural log, the quotient rule is just the 4x plus 6 over the x plus 5, okay? Quotient rule, because of the minus. And that equals ln of x, natural log of x. Now this time, remember, this must just equal this. I don't really need the word log there, because it's like me saying, well, the log of 2 equals the log of 2. Well, of course it does, because 2 equals 2. 2 is 2, okay? So I actually don't need this. Okay, just think about it, okay? So again, we get to here. Again, logarithmic equality. So you could think of this as multiplying both sides by x plus 5. You can write the x as x over 1 and cross multiply. We end up with this. Okay. So again, solving for 0. We get this. We factor. We'll end up with -3 and +2. But look, -3, 4 times -3. Okay, it works there. It won't work there. If I put -3 into there, it will not work. Okay. So again, 2 is the only solution. Okay,